Hello everybody and welcome back. This video is on sections 4.1 and 4.2. It's called Exponential Functions. Quite an important topic in all of mathematics. There's some really heavy things coming here which you'll do later. But we're going to just introduce exponential functions and I guess just recall a linear function has constant growth. Constant growth. Such as f of x equals 2x. And so it's growing constantly as it goes. Where an exponential function has a percentage growth. Exponential has a percentage growth. And that's important. As it gets bigger, it gets bigger. Or smaller, it gets smaller. As the thing grows, it grows bigger. And the graph, this is y equals 2x, f of x equals 2 to the x, looks like this. That's an exponential function. And so that's what we're going to be talking about, these exponential functions. This is an exponent, the variables in the exponent. And so if you consider f of x equals ab to the x, that's called an exponential function because the variable is the exponent. It's called an exponential function. B, by the way, A is the initial value, and it can be any real number. And A is a real. It's a real number. B is pretty interesting. It's called a base, and it can't be 1. It can be any number greater than 0, but not 1. Because if b was 1, this would be 1 to the x, so it would just be f of x equals a. It would be a horizontal line. The domain, you can put anything in here, is all the reals. You can put anything at all in there for x. The range, on the other hand, if b is bigger than 1, then the range goes from 0 to infinity. If b is less than 1, then it goes from negative infinity to 0. Here, real quick, I'll just a picture of this. This is boop, like that. This one is boop, like that. If b is less than 1, it looks like that. If b is greater than 1, it looks like that. Whoa, that's the same thing. Jesus. I'm sorry about that. B greater than 1, B less than 1. So that's that, exponential growth. So a whole bunch of things come out of this. Let's just go straight here. The number e. Perhaps, let me write an equation. The number e. E is an irrational number. It's a natural base for exponential functions, and in fact the inverse of the number e is called the natural log. Everything's natural. E is defined as this number, 1 plus 1 over n to the n, as n goes to infinity and just gets bigger. If you think what we're talking about here, e is, let's see, actually we could write it as n plus 1 over n, which is the same thing. Meaning, okay, 6/5 to the 5th. Check that out on a calculator. Or 48 47th to the 47th. Check that out on a calculator. And it's approaching, all this is approaching e, which is approximately 2.71, 282, I think, something like 2.71 is e. It's an irrational number right here. This is perhaps the most important equation in at least numerical mathematics, probably in all of pure mathematics. E to the pi I plus 1 equals 0. It's called Euler's equation. By the way, this is called Euler's number. And because of the constants, 1, 2, 3, 4, 5 constants in this equation, they're the most important constants in all of mathematics. This is a Calculus 2 topic. Chapter 10. And this is, by the way, this is when it really starts getting cool. So now we graph, I have to erase. Now we're going to graph these things, and they all look exponential. They all look exponential. Graphs. I guess we'll just start with what f of x equals 2 to the x. 2 to the x. And so, first off, here's what it looks like. You know, at that point is the point where x is 0 and y is and f of x is 2. Yeah, we'll put that there. And it goes like this, and it gets exponentially bigger. 2 to the first is 2. 1, 2. Here's 3, 8. Something's wrong. 0, 1. I'm sorry about that. Yeah, I knew something was wrong. This is 1, 2. Of course, all of them. The y-intercept is 0, 1. So that's 2 to the x. Now here's f of x equals a half to the x. It just goes this way. Where again, that's the point 0, 1. Here's the point 1, 1 half, 2, 1 fourth. How about 3, 1 eighth? By the way, over here is negative 3, 1 eighth. And it goes, well, here's 3, 8. Negative 3, 8 rather, where 3 8. So those are two pictures of, they're called inverse functions actually, of one another. So that's just a brief snapshot of graphs. Now the characteristics of these graphs, because we're going to move them up and down and right and left and stuff. So let's get to know what the heck they are. They're all one-to-one characteristics of the graph of an exponential function. They're all one-to-one. That's first. So of an exponential f of x equals b to the x. So that's the exponential function. B is always greater than 0. Well, it's not always. We can talk about what happens when b is less than 0. It reflects it. It reflects it on this axis. That's it. Oh, b can't be 1. Because if b was 1, that's just 1 to the. It's just f of x equals 1. So it's a one-to-one function. The y equals 0 is a horizontal asymptote. Note, horizontal asymptote. That never crosses that line. Ever could that cross the line. The domain is the reals. All the reals. The range is either from 0 to infinity or from negative infinity to 0. This is when b is less than 1. This is when b is greater than, 1. And the intercept, the y-intercept here is where 0, 1 for all. You know, if I put a 0 in here, 2 to the 0 is always 1. That's why that's 0, 1. And it'll be decreasing. Here, let's do that one more thing. Decreasing when b is less than 1, and of course increasing b is greater than 1. Sorry, I'm so low. Increasing, decreasing functions. I just want to talk about transformations. We're just going to put this over here. Yeah, and then these two sections will be finished. We're keeping this as simple as we can. Right now is where some heavy work comes in, but again, I just want to introduce them to you. Transformations of exponential functions. Well, let's just say f of x equals b to the x. And we'll just transform it, and we'll write down what happens as we do. How about a vertical shift? Would be f of x equals b to the x plus c, some number, then it shifts by c, up or down. Horizontal shift. So we are now moving it right or left. We're moving it this way or that way. F at x equals b to the x plus c, where the c is now in the exponent. Excuse me, stretches or compressions. You put a number in front of there. A to bx, right? This would be f at x equals a times b to the x. It's a stretch if a is greater than 1. It's a compression if a is less than 1. Oh, the absolute value. Stretch, absolute value of a greater than 1. Compression, absolute value of a less than 1. Whoops, less than 1. And just one more thing, reflection. F at x equals negative, opposite of b to the x. A reflection means if the thing looks like that, this is b to the x. Reflection would look like this. Negative b to the x. Of course, it would be reflected by be reflected on the over the x-axis. All right, that's it. I appreciate. See you soon.